Thank you so much. We have been talking about negative emission technologies and carbon sequestration, but I would like to highlight that the carbon sequestration is only one ecosystem service. There are other ecosystem services beyond carbon sequestration, and I would like to highlight the role of soils in carbon sequestration and other and delivering other ecosystem services. So, I will be focused on the reforestation processes. So, I will show you our theoretical framework about how soils are responding or would respond to some reforestation processes. First of all, I would like to show you a little bit the theoretical model, which is basically the soil has different components, soil properties, but we can affect with our management drivers, external drivers, natural or anthropogenic, the soil properties in a good way. So we can increase the soil formation, but we can affect negatively the soil, and we can degrade the soil. This is basically how soils are functioning. But the thing is that we are affecting other ecosystem services and eventually the human well-being. So, why is soil organic carbon important or so important in ecosystems in general? Because, first of all, soil organic carbon is a key indicator of soil quality and thereby soil security. Second one, the soil organic carbon is the main driver of most supporting functions. The third one, and we are in a conference about resilience, a soil with very low organic carbon content is a soil with less resilient properties. So the ecosystem is less resilient with a lower soil organic carbon content. And there you can see a lot of properties that soil organic carbon is affecting positively. But soil organic carbon is not only one pool, because usually people talk about increasing soil organic carbon content or affecting positively or negatively soil organic carbon content in general. But the thing is that soil organic matter is a mix of very different compounds, thousands of different compounds, chemical compounds. But according to the dynamics, we can distinguish two big groups of soil organic carbon pools. The first one is that this one, the unprotected soil organic carbon, is the soil organic carbon which is accessible to soil microorganisms. So, this soil organic carbon is not sequestered because it's accessible to soil microorganisms and it can be easily degraded to CO2, to the atmosphere. But importantly, we have other carbon pools with the name is protected soil organic carbon. Why? Because this organic carbon is placed in a way that the soil microorganisms cannot access to this organic carbon. So it's the organic carbon which is really sequestered into the soil. And the most important thing, this organic carbon which is protected depends on soil properties, depends on the texture of the soil, especially these two fractions. And the consequence is the following. There is a limited capacity of the soil to accumulate soil organic carbon, which is really protective. And this is the theoretical function. So, in a natural forest, for instance, we have next to the climax, we have this situation. The organic carbon into the soil, which is really sequestered, is near the saturation limit. But what happened when we apply different management in forest? We are decreasing the incoming organic carbon to the soil, and therefore we are decreasing the soil organic carbon content. So you can see we are decreasing. For example, when we are thinning the trees, when we are cutting or reducing the cutting edge of the tree. But it's very important the shape of the function, because at the beginning, if we apply some management, the decrease in the soil organic carbon content is not very high. But there is a point where decreasing the soil organic carbon, the incoming biomass, would decrease a lot, very strongly, the soil organic carbon content, and therefore the resilience of the ecosystem. So it's very important monitoring not only soil organic carbon, total soil organic carbon content, but also different soil organic carbon pools, right? But, okay, cool. This is about soil organic carbon content, but what happens with other ecosystem services? We have to go beyond carbon sequestration. Okay, this is what happens in a natural forest. There are not management. So we are producing biomass, we are increasing soil organic carbon content, we are affecting positively the soil functions and the water supply, and we have carbon sequestration. Good. This is a natural situation. But what happens when we extract timber? When we extract timber, we are increasing biomass production, but we are removing the biomass production which is produced. So we are decreasing the soil organic carbon content, we are affecting negatively the soil functions, we are affecting negatively the water supply, and we are affecting negatively the carbon sequestration. And the consequence is that we are affecting negatively the soil formation, the nutrient cycle, the biodiversity pool, and the water cycle. We are decreasing the soil resilience. We are affecting negatively the ecosystem resilience. And in the future, it is possible that we affect negatively the timber production because we are affecting negatively the soil functions. Biomass is placed on soil. This is very logical. Sometimes people forget it. But it is possible to change the situation without affecting the carbon sequestration. I mean, we can, for example, increase the tree species diversity. What happens if we increase the tree species diversity? We are affecting positively the biomass production, but we are not affecting positively, in principle, we are not affecting positively the soil organic carbon content, but we are affecting positively the soil functions. This is very important because we are affecting positively, for example, the water supply. So even though we are not affecting positively the soil organic carbon content, we are not increasing the soil organic carbon content, we are increasing other ecosystem services delivered by soils. So there you can see a summary of the results. And other benefit of increasing the tree species diversity is that we are affecting positively the capacity of the ecosystem for the adaptation of climate change. So we have more species, diverse species, and we can fight much better against future risks derived from climate change. I want to show you two images. And I think I have some time. Like 3 weeks ago, one friend of mine told me, okay, we are going to the forest. And in my mind was this one. Okay, I'm going to the forest this weekend, but no. We went to this forest. And I was surprised because in my mind was this kind of forest. So I was thinking about, okay, this is also a forest. This can be also a reforestation or afforestation process, but this is a tree plantation. And how soil is affected in this case, and what's the difference between this case and this case? You can see here there are some leaves, but there are not a lot of dead or living organic matter. the tree diameter is much lower, and there are, I'm sorry because you cannot see the words, but for instance, what happened with the biodiversity here and the biodiversity here? Completely different. And what happened? This is the resilience. What will be the resilience of this ecosystem and this ecosystem? Both are maybe afforestation processes or reforestation processes, but the consequences in other ecosystem services delivered by soils would be completely different. Maybe the carbon sequestration is similar, the amount of carbon sequestration, but the consequences to the ecosystems could be completely different. So, I want to talk about, I was talking about the diversity, redundancy, so the natural components of the resilience. Okay, we can manage the slow variables, we can increase connectivity, diversity, but there are other variables of the resilience which are not natural variables, are very related to the governance system. The thing is that we cannot increase all the ecosystem services. We cannot increase the carbon sequestration, the ecosystem resilience, all the ecosystem services. It's not possible. We have to decide which ecosystem services are our priority. And who decides this kind of thing? My question is soil degradation a priority for policymakers in mid-latitude countries? And the second one, are people and also researchers aware of the importance of soils in delivering ecosystem services? Thanks.